Hello students, hope you all are good. Today we will discuss the functions of operating system. So let's get started. As we all know, an operating system acts as an interface between users and hardware. The basic functions of operating systems are input-output control, resource allocation, file management, process management, error reporting, and memory management. We group all the functions of operating system into the four main categories. These are process management, memory management, file management, and device management. Now let's understand what is memory management. Memory management refers to the management of primary memory or main memory. Main memory is a large array of words or bytes where each word or byte has its own address. Main memory provides a fast storage that can be accessed directly by the CPU. For a program to be executed, it must be in the main memory. An operating system does the following activities for memory management. OS keeps tracks of primary memory, that is, what part of it are in use by whom, what part are not in use. Next, it selecting the allocation policy for the memory. It coordinates the memories. In multiprogramming, the operating system decides which process will get memory, when and how much. Memory management allocates the memory when a process requests it to do so, and it deallocates the memory when a process no longer needs it or has been terminated. There are some techniques which is used in memory management. The first technique is single contiguous allocation. Single contiguous allocation technique is the easiest memory management technique. In this method, all types of computer's memory except a small portion which is reserved for the OS is available for one application. That is, in this policy, the memory is allocated to the single job. For example, MS-DOS operating system allocates memory in this way. An embedded system also runs on a single application. The advantages of single contiguous allocation is it is the simplest among all the allocations and doesn't require any expertise to understand and use the system. But there is a disadvantage of single contiguous allocation, that is poor utilization of main memory and processor. Next technique is partitioned allocation. It increases the complexity of operating system. It is allowed to have more than one job in main memory at one time. The system can utilize all the resources in efficient manner. It divides primary memory into various memory partitions, which is mostly contiguous areas of memory. Every partition stores all the information for a specific task or job. This method consists of allotting a partition to a job when it starts and unallocated when it ends. Here we have used the term multiprogramming. So let's understand what is multiprogramming. The technique of allowing more than one job to reside in the memory is known as multiprogramming. The number of jobs reside in the memory is called the degree of multiprogramming. And the next technique is paged memory management. This method divides the computer's main memory into fixed size units known as page frames. This hardware memory management unit maps pages into frames which should be allocated on a page basis. The physical memory is divided into pieces of same size called blocks. Any page can be placed into any block. The pages are logically contiguous, but the block need not be contiguous. The advantage of paged memory management is it eliminates fragmentation and increase the degree of multiprogramming. And the disadvantage is it increases the cost of the system. Because in this technique, we need the hardware to map the page address generally increases the cost of the system and it also slows down the processor. In multi-programming environment, when the system is allocated to the next user, the current contents of the user memory were written out to a backing store and the contents of the next user read in. This is called swapping. Swapping is a method in which the process should be swapped temporarily from the main memory to the backing store. It will be later brought back into the memory for continued execution. Backing store is a hard disk or some other secondary storage device that should be big enough in order to accommodate copies of all memory images for all users. It is also capable of offering direct access to these memory images. Here we can see an example of swapping. Next function of an operating system is device management. The device management part of operating system manages and utilizes the different devices in an efficient manner. It manages all the input and output devices. The main functions of the device manager are monitor the status of all devices, including storage drives, printers, and other peripherals. Enforce preset policies on which process gets which device for how long. Deals with the allocation of devices to processes and deals with the deallocation of devices to processes both at a temporary basis, for example when the process is interrupted, and on the permanent basis, for example when the process is completed. The examples of devices are keyboard, mouse, monitor, scanner, camcorder, CD-ROM, USB ports, webcam, microphone, printers. These all are managed by the function device management of the operating system. There are three main types of devices in the device management: dedicated device, shared devices, and virtual devices. Let's understand the dedicated devices. These are the devices that are assigned to one process at a time, and the process only releases the device once it is completed. This makes sense for devices like plotters and tape drives. The problem with this is that it means only one user is using it at a time, and it might be inefficient if the device isn't being used 100% of the time that it is being logged by the user. Here we can see an example of dedicated device, which is a plotter. Now understand what is shared device. So these are the devices that can be shared between the several processes. Considering an example like a hard disk, it is shared, but interleaving between different processes requests. All conflicts for device need to be resolved, but predetermined policies to decide which request is handled first. This is the hard disk drive and it is the best example of shared device. Let's understand what is virtual devices. So these are devices that are combination of dedicated and shared devices. So a printer is a dedicated device, but using the spooling, that is queues, means it can be shared. A print job isn't sent straight to the printer. Instead, it goes to the disk, means spool, until it is fully prepared with all the necessary printer sequences and formatting. Then it goes to the printer, ensuring that the printers and all the input output devices are used efficiently. This is the example of virtual devices. Next function is file management. So now understand what is files and directories. A file is a collection of data that is stored on disk and that can be manipulated as a single unit by its name. And a directory is a file that acts as a folder for other files. File management deals with the management of data and programs which resides on the secondary storage device. The file manager keeps track of where files are stored, determines how the files are stored, follows operating system file allocation policies, uses available storage space efficiently for files. It creates a record of all file usage. It allocates a file to a user if it is free and if they are permitted access to it. And it deallocates files when user finished with it. As files can be implemented on several devices like disks, tapes and other secondary storage devices, there are some basic operations that can be performed on files. These are create function. The operating system must find space in the file system and add an entry to the directory. Write, that is, OS must find the location of a file and usually keeps a write pointer that indicates where the next write will occur. Read, OS must find the file and usually keeps a read pointer that indicates where the next read will occur. Reposition within a file, it changes the file position pointer to a given value. We can delete the file, that is, release the space allocated to a file and update the directory. And operating system, truncate a file, that is, it erase the contents of a file but keep its attribute. So these are the basic functions which can be performed on a file. There are some common file extensions. In a multi-user environment, the file protection is necessary because a file is shared by the multiple users. The several mechanisms to support the protections are password and access lists. So let's understand what is access control list. This list may contain the username and the types of the access allowed for each user. The operating system checks this access control list associated with a file whenever a user requests an access to a particular file. But one limitation of access control list is their length. So we create groups. And the second option for file protection is through password. Files can be protected by a password. The owner of a file can control its access by assigning a password. Thus, only those users who know the password can access a particular file. And the next function of operating system is process management, which is a very important function. So first understand what is a process. So let's understand it. A process is basically a program while it is being executed. A program is a passive entity, whereas a process is an active entity. So the process management is concerned with the management of physical processor. That is the allocation of processes to a processor. Here we can see the process concepts. So first is process hierarchy. Operating system needs some way to create and kill processes. When a process is created, it creates another process, which in turn creates some more processes, and so on, is called process hierarchy or process tree. Next is process states. So the lifetime of a process can be divided into several stages as states, each with certain characteristics that describes the process. It means that as a process starts executing, it goes from one state to another state. Each process may be in one of the following states. So the process states are new, running, waiting or suspended, ready, and terminated. So when a process is created, it is in new state. In running state, the instructions are being executed. In waiting state, the process are waiting for some event to occur. In ready state, the process is waiting to be assigned to a process. And in terminated state, the process has finished the execution. So this is the process states diagram. Let's understand process scheduling. As we all know, scheduling is a fundamental operating system function. All computer resources are scheduled before use. Since CPU is one of the primary computer resource, its scheduling is central to operating system design. CPU scheduling is the basis of operating system, which supports multi-programming concepts by having a number of programs in computer memory at same time. The main objective of scheduling is to increase CPU utilization and higher throughput. Basically, there are two types of scheduling: primitive scheduling and non-primitive scheduling. Here we can see the difference. So primitive scheduling is when a computer process is interrupted and the CPU's power is given over to another process with a higher priority. This type of scheduling occurs when a process switches from running state to a ready state or from a waiting state to a ready state. And the non-preemptive scheduling is one the CPU has been allocated to a process. The process keeps the CPU until it releases the CPU either by termination or by switching to waiting state. So types of scheduling algorithm is categorized into two categories. First is basic strategies and second is combined strategies. So in basic strategies, we have to read first in, first out or first come, first serve scheduling, round robin scheduling, shortest job first serve scheduling, and priority. And in combined strategies, there are multi-level queue and multi-level feedback queue. So for now, we have to read only FCFS, round robin, and shortest job first serve. So before understanding the scheduling techniques, let's understand what is turnaround time, waiting time and response time. So the turnaround time is the sum of time spent in the ready queue, execution time and input output time. That is, to find the turnaround time is very simple. Minimize the time of submission to time of completion. Next is waiting time. Uh, to find the waiting time, we have to minimize the time spent in ready queue minus affected solely by scheduling policy. And response time is the amount of time it takes to start responding to a request. This criterion is important for interactive systems. So to find the response time, we have to minimize the time of submission of a request from the time of first response. This is the first scheduling technique, that is first come first serve. This is the non-preemptive technique and it is also known as FCFS. It handles jobs according to their arrival time. The earlier they arrive, the sooner they will served. This technique used the algorithm which is first in first out queue. It is good for batch system, not so good for interactive ones, but the turnaround time is unpredictable in first come first serve scheduling technique. This is the simplest scheduling technique. Here we can see an example of first come first serve scheduling technique. There is a table which contains process and the burst time. Suppose that the processes arrive in the order P1, P2 and P3, then the Gantt chart for the scheduling is given below. Here we have to find the waiting time and average waiting time. So the waiting time for P1 is 0 because P1 does not have to wait for any process to get completed. So the waiting time for P1 is 0, but the waiting time of P2 is 24 because the burst time of P1 is 24 unit of time. That is, P1 takes 24 unit of time to get completed the task. That is, to get executed. So, P2 has to wait for P1 to get executed completely. That is why waiting time of P2 is 24 unit of time. And in the same way, P3 has to wait 24 plus 3. That is the waiting time of the burst time of P1 plus the burst time of P2, that is 27. Therefore, the waiting time for P3 is 27. Here we have to find the average waiting time. So it is very simple. Add the waiting time of these three processes, that is 0 plus 24 and plus 27, and then divide the sum by 3 because there are 3 processes. So it will become 17 unit of time. So this is the simplest way of scheduling. FCFS is the simplest way of scheduling. In this, scheduling are served in the order they have arrived. It uses the first in first out queue system. The second technique is shortest job first serve. So it is also non-preemptive or sometimes it is preemptive. This policy handles jobs based on the length of their CPU cycle time. That is, uses lengths to schedule process with shortest time. Optimal gives minimum average waiting time for a given set of processes. Optimal only when all the jobs are available at same time and the CPU estimates are available and accurate. It doesn't work in interactive system because users doesn't estimate in advance CPU time required to run their job. This is the example of shortest job first serve preemptive. Here we can see a table in which it is written the processes, arrival time and the burst time. So in the same way, we have to find the waiting time for P1, P2, P3 and P4 and the average waiting time. And the next technique is round robin technique. This scheduling is primarily used in time sharing and in multi-user system where the primary requirement is the good response time. In this scheduling algorithm, the CPU time is divided into time slices. Each process is allocated a small time slice while it is running. No process can run for more than one time slice when there are other waiting in the ready queue. If the process requires more CPU time, then it should go in the end of the ready queue. So we can say FC round robin is FCFS with preemption. It used extensively in interactive system because it is easy to implement and it's based on job characteristics but on a predetermined slice of time that is given to each job. Time slice is called a time quantum. That is size crucial to system performance 100 ms to 1 to 2 seconds. Here we can see the example of round robin. In the operating system scheduling technique, sometimes a very different kind of situation occur which is known as the deadlock situation. So the types of deadlock situations are process deadlock and system deadlock. A process is deadlocked when it is waiting on an event which will never happen. And a system is deadlocked when one or more processes are deadlocked. Under normal operation, a resource allocation proceeds like this: request a resource, use the resource, and then release the resource. Thank you for watching the video. Thank you so much, guys.